In this next session, Next Generation Colour and Finishing, we're going to explore how innovations in dyeing and finishing are helping to reduce chemical use, water consumption, and overall environmental impact. And I'm delighted to welcome up on stage Professor Stephen Russell, Director of the Leeds Institute of Textiles and Colour, LETAC. Steve will highlight the vital role that research and development plays in driving innovation in colouring and finishing. Steve.
Good afternoon, everyone. Just checking. I've taken the liberty of slightly changing the title to Colouration, Dyeing and Finishing, so forgive me for doing that. I'm just going to try to speak for a very short time, 5 minutes, to give you a little bit of perspective into why coloration, dyeing and finishing is important from a research perspective. And then the real heroes today will be the spotlights that follow. I don't advise you to look at this image on the right-hand side for too long because it is quite hypnotic. I'm doing an experiment now just to see how many people nod off. The first thing to say is it's important because dyeing and finishing is the way that we build functionality into fabric beyond the fibres we choose and the processes that we use to make those fibres into textile products. So in a way, it's the last stage we have available to chemically modify or mechanically modify fabrics so they're fit for purpose. And don't think it's only relevant to clothing and fashion. It's relevant to technical textiles as well. So whether we're talking about water repellents, flame retardants, antimicrobials, softeners, wrinkle resist chemistry, I could do with some of that, binders, coatings, these are all chemicals that are applied to fibre yarn fabrics. Most of it's applied at the fabric stage to provide extra function. And on top of that, we use a large amount of chemicals as processing aids as well. Those aids don't even stay with the fibre. We wash them off. So that's why it's important from a technical point of view, but there are some challenges, predictably. And the challenges are that to put these chemicals on, we need a vehicle called water, and we need temperature, and temperature is normally generated by heating, which, if it's coming from fossil fuel-based sources, creates lots of greenhouse gas emissions. So a very sensible thing to do, first of all, before we think about next-gen anything, is to reduce each of the inputs required to dye and finish a kilo of fabric or yarn. So globally, we're using, I tried to do a calculation a few days ago, but it's well over 10 million tons of material, chemicals for the clothing industry on its own before we even add technical textiles. And these are chemicals which in some cases are being regulated out. And unfortunately, some of those chemicals are really, really useful. PFAS is a good example. These perfluoroalkyl compounds and polyfluoroalkyl compounds, they have both the ability to repel water and, more importantly, oil. We've been trying for 20 years or more to come up with chemistry that will perform as well as those chemicals, but it's really difficult. So there's a whole load of chemicals that we're using for different purposes, and then we're using salts, anti-static finishes, surfactants, detergents, all of which are just used during processing and then removed. We don't even see them on the finished fabric. Okay, so there's a lot there to consider. The first three images here are all courtesy of generative AI. I was entertaining myself. They were actually they were better than I could come up with. So just to let you know, the final image is actually one that was created by John Lewis and University of Leeds. But there's a lot more going on than I'm implying here. But I just wanted to pick out a few areas quickly. The use of machine learning to disrupt forecasting, colour forecasting in particular, harvesting social media data to get closer towards nowcasting, what is trending now in country A or demographic situation B, or even individual trends, right? So matching colour preferences to individual people. Also product-specific colour forecasting, right? So a man's jacket is very different to a lady's blouse, or interior furnishings very different to clothing. So the colour trends can be then stratified using data-driven approaches. New processes capable of reducing water consumption and chemical load. Processes like supercritical CO2, digital spray jet systems that we'll hear about shortly, even ozone pre-treatment for the processes that precede dyeing, all in order to reduce water consumption and the chemicals loads that are involved in those processes, as well as the temperature and heat required, and therefore reducing the associated emissions. And then if we move on further, this business of trying to make dyes recyclable. So if you like, easy on, easy off, preferably not easy off when you're wearing it or using it later on, because these chemicals, particularly if they're covalently bonded to the fibre, act as disruptors for recycling. So you could have a 100% cotton garment that's been dyed and finished or coated, and those chemicals then muck up the recycling process. Technically, you can deal with it, but economically, you could kill it. So these are additional complications. Can we get chemistry off as easily as we put it on in order to enable full life cycle management of the product? I haven't even had a knowing look from, but I've finished now, you'll be pleased to know. Apart from my final slide, I looked at this, I didn't know this was completely serendipitous, but I think pretty much all of these companies that we're about to hear from in the spotlights came through the Future Fashion Factory programme that we ran out of Leeds with other academic partners and other industrial partners, which UKRI funded back in 2018. And of course, FFF was chaired by UKFT. So it's really delightful for me to be here. And again, welcome back on stage some of these companies, apart from Switch Dye, which of course, I think some of you know is a Leeds University spin-out. End of blatant publicity, thank you.